Welcome to Shifting Grids. We've been doing the topic quadratic expressions and equations, and in this session I'll be teaching the graphs of quadratic functions. Therefore, a function of the form y is equals to a x squared plus bx plus c is called a quadratic function. It's a quadratic function. It's a quadratic function. So a form of a function which is in this form, we call it a quadratic function. And we usually believe that the main point, for every point of x, there is a unique point of y. Therefore, for every value of x, there is always a unique value of y corresponding to the given value of x. Therefore, what basically we do here is to find when a function has been brought of this form, you're given a range of values of x so that you may fill a table writing the values of y which are corresponding to the given values of x. Then now you'll be taking the values of x and the values of y in this order, and you place them as coordinates in a Cartesian plane. Therefore, let me submit an example of a quadratic function, and we see how we can come up with a table, fill the values of y, and continue to plot the coordinates so that you may see the type of a graph we will get when we plot a quadratic function. Therefore, if you thought, for example, draw the graph of y is equals to x squared minus 2x minus 3. Y is equals to x squared minus 2x minus 3 for the values of y, for the values of x between negative 2 and positive 4, x ranging between negative 2 and positive 4. Plot a graph of this function. Then the values of x, we use the ones ranging from negative 2 to positive 2. Therefore, the first thing I've said, you come up with a table of functions whereby you will have the values of y and the values of x said for every value of x, there is a unique corresponding value of y. So we start from negative 2, negative 1, 0, 1, 2, up to 4, 3, then lastly 4. So this is the table we will fill. We've said for every value of x given, there is a corresponding unique value of y. Therefore, we now see that y is given by x squared minus 2x minus 3. Therefore, when x is negative 2, we substitute it in this expression so that you may get the corresponding value of y. Therefore, when x is negative 2, we'll have negative 2 squared minus 2 into negative 2 minus 3. Therefore, 4 minus 2 by negative 2, it becomes plus 4, then minus 3. So this is 8 minus 3, we get positive 5. The next is when x is negative 1. Therefore, again, we come to the function and we substitute when x is negative 1. Therefore, negative 1 squared minus 2 into negative 1 minus 3, and this becomes 1 plus 2 minus 3. So this is 3 minus 3, we get a 0. When x is 0, this becomes a 0, this becomes a 0, therefore we remain with y as negative 3. When x is positive 1 now, we substitute again now positive 1, and substituting positive 1 in this function, y will be 1 squared minus 2 times 1 minus 3. So 1 minus 2 minus 3. It becomes 1 minus 2, we get negative 1. Negative 1 minus 3, we get negative 4. We get negative 4. We have the next value of x as 2, therefore we replace 2 in the same function. Replacing 2 in this function, we'll have 2 squared minus 2 into 2 minus 3. Therefore this is 4 minus 4 minus 3. 4 minus 4, 0, minus 3, we get negative 3. Then when x is 3, we substitute again in this function. When x is 3, we'll have 3 squared 9 minus 2 into 3 minus 3. Therefore 9 minus 6 minus 3. So 9 minus 6, negative 3. Positive 3, sorry. Positive 3 minus 3 is a 0. The lastly, when x is 4, we substitute 4 in the function. Where we have x to negative 4. Therefore, 4 squared, we get 16, minus 2 times 4, we get 8, minus 3. Therefore, minus 16 minus 8, we get positive 8, minus 3. This gives us a 5. Therefore now, for the values of x provided, we have gotten the corresponding values of y by substituting the values of x in the given function. Therefore now we will be plotting x, y in that order as coordinates on a Cartesian plane, and we will see the graph we shall obtain. Let's now plot it. And first start by drawing a Cartesian plane. And start by plotting a Cartesian plane. We have the values ranging between negative 2 to positive 4. Zero, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, negative 1, negative 2, negative 3, negative 4. So these are negatives, these are also negatives. For the x-axis, these are positives. For the y-axis, these are positives. So we shall have 1, 2, 3, 4, 5, 6. Therefore now, we now start plotting the coordinates there. Let me focus on the coordinates also. Yes. So we have the first one, negative 2, positive 5. Negative 2, positive 5. Put us. Then after that, the next one is negative 1, 0. Negative 1, 0. Just here. Again, 0, negative 3, 0, negative 3. Then 1, negative 4, 1, negative 4. 2, negative 3, 2, negative 3. Then we have 3, 0, 3, 0. Then the other one is 4, positive 5. So 4, positive 5. So that is it. Those are the coordinates. Now we join them using a smooth line without any bends and without lifting the pencil. So using again another note, whenever you're coming up with the quadratic curve, you should ensure that after you have plotted the curve, your dots should remain visible, either a dot or a cross. They should remain very visible. So let me focus on the graph now. So we want to join these dots to come up with a quadratic graph. Therefore, from this one, so that is how we come up with a quadratic curve, and we name it. So you see, after the curve has been drawn, the dots should remain visible where the curve is passing. They should remain still visible. So this is the curve y is equal to x squared minus 2x minus 3. So this is the name of the curve. That is the name of the curve. I would like us to see another one example of how a curve can be drawn. Therefore, if you are taught to draw the graph of, for example, let me now bring another curve. Draw the graph of graphs of quadratic functions. When you are taught to draw the graph of, then the function given draw the graph of y is equals to 8 minus 2x minus x squared. For the values of x, between negative 4, for the values of x between negative 4 and positive 2. Draw the graph of the function. Draw the graph of the function. So the given function is here. Draw the graph of the function. Y is equals to 8 minus 2x minus x squared. For the values of x between negative 4 and positive 2. Therefore, we'll draw a graph. Solution. We start with the table of values. The table of values, wherever we shall have values of x, then we determine the corresponding value of y. Determine the corresponding value of y. Negative 4, negative 3, negative 2, negative 1, 0, 1, lastly 2. So that is how the table is. Now we start filling the desired values of y, and y is gotten by minus. So we start substituting now when x is negative 4. So 8 minus 2 into negative 4 minus negative 4 squared. Therefore, this should be 8 plus 8 minus negative 4 squared. We get it as 16. Therefore, 16 minus 16, we get a 0 here. When x is negative 3, when x is negative 3, what shall y be? 8 minus 2 into x, which is negative 3, minus 2 into x, which is negative 3, then minus x squared, sorry, minus negative 3 squared. So this shall be 8 positive 6 minus 9. So this will be 14. 14 minus 9, we get 5. The other value of y will be when x is negative 2. Therefore, 8 minus 2 into negative 2 minus negative 2 squared. So this is 8 positive 4 minus 4. So we get 8 here. We get 8 at level. Then another point is when x is negative 1. Therefore, we fill negative 1 wherever we have x. So 8 minus 2 into negative 1 minus negative 1 squared. Therefore, this shall be 8 plus 2, which is 10, minus 1. We get 9. We get 9. Then, when x is 0, when x is 0, we remain with 8. When x is 0, just remain with 8 because everything else becomes a 0 in this function. Yeah. Then when x is 1, we shall have, when x is 1, we shall have y as 8 minus 2 times 1 is just 2 minus 1 squared is just 1. Therefore, 8 minus 2 minus 1, we get a 5. When x is 2, when x is 2, we shall have 8 minus 2 into 2, which is a 4. Then minus 2 squared, which is a 4. So 8 minus 4 minus 4, it becomes a 0. It becomes a 0. So that is the desired table of values. Let me now bring them in the Cartesian plane. Let's now plot the points on a Cartesian plane or on a graph page. So we will have the values of y, the highest being a 9, meaning we need a bigger part of the y coordinates being positive. Therefore, we can put the x-axis as low as possible so that we may have a 9 being accommodated. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is enough. So we'll have 0, 1, 2, 3, negative 1, negative 2, negative 3, negative 4, negative 5. Then 1, 2, negatives. 1, 2, 3, 4, 5, 6, 7, 8, 10. Therefore, now we can plot the coordinates. We can plot now the coordinates. Coordinates now. Negative 4, 0. Negative 4, 0. So this point. negative 3, 5, this one, negative 2, 8, negative 2, 8, this one, negative 1, 9, negative 1, 9, this one, 0, 8, 0, 8, there, 1, 5, 1, 5, then 2 and 0, so 2 zeros here. Therefore, those are the coordinates. You can check they are suggesting a smooth curve. Therefore, we join them smoothly so that we may get the curve. Joining them, we shall come up with a curve of this nature. So this is the curve which will be obtained when the points are plotted carefully. The curve is y is equals to 8 minus 2x minus x squared. So that is how the curve is plotted. In the next lesson, I'll be showing how graphs can be used to solve quadratic functions and simultaneous equations which involve a quadratic function. So thank you very much for following. We can meet for the next class later. Subscribe to Shifting Grades and share our link with your different friends. Thank you.